This video is the titration of a strong acid with a strong base. I'm going to do the titration of 20 milliliters of 0.2 molar HCl with 0.1 molar NaOH. And the first step in any titration is to find the equivalence point. So the reaction that we have is HCl plus NaOH yields water. You should know how to do this, plus sodium chloride. And I do an initial final table because they're strong acids. I have 0.2 millimole, excuse me, messed that up. Set that up again. I don't want to do initial final. I have 0.2 molar HCl and I have 20 milliliters, and I have 0.1 molar NaOH, and I want to know the volume to react all the HCl. That will be the equivalence point. So this is straightforward freshman chemistry. 20 milliliters of HCl times 0.2 moles of HCl per liter of HCl. Notice I'm leaving out the solution part. That's okay. And it's 1 mole of HCl per 1 mole of sodium hydroxide. And then I have 0.1 mole of NaOH per liter of NaOH. Now, watch what happens. You'll notice, you might have noticed that over here, I did not do the conversion from liters to milliliters to liters. But if I do my canceling, my moles of sodium hydroxide cancel, my moles of HCl cancel, my liters, I can think about this in terms of liters here and liters here. So those cancel. My HCl cancels here. I'm going to make it a different color. HCl cancels here and here. And I end up with the units left over are milliliters of sodium hydroxide, which is exactly what I want to know. And so I do my calculation and I get the equivalence point. Oh, let me change that out again. The equivalence point, VE, is equal to 20 times 0.2 divided by 0.1 is 40 milliliters of sodium hydroxide. A lot of times you can do this in your head, but I thought I'd show you this one time. Now, the second step is to make a table. And once we have that, we set up a table. And I'm going to make a long table because I'm going to go through a lot of calculations. You won't have to do them all. I'm going to pause this while I do it. Okay, I've got this going again. The volume of sodium hydroxide is up here at the top. I got the volume total because the volume is going to be changing. I'm going to calculate the concentration of H3O plus or OH minus. It will vary, and you'll see how that works, and the pH. And these are the volumes I want to do it at. 0, 1, 10, 20, 30, 39, the equivalence point 40, and I drew a line right under the equivalence point because this is where people mess up. After that point, I'll be doing OH minus, and that's the concentration I'll be calculating at 41, 45, and 60 of sodium hydroxide. So these parts are the acid parts. So the very first point, volume equals 0, is really easy. The concentration of H3O plus is equal to the concentration of HCl, and that will be equal to, I forgot what we chose, 0.2 molar. So it's 0.2 molar. and I'm just going to put volume total is 20. Oops, gotta get rid of that. Pause it. Volume total is 20. Volume total, we'll try this one more time, is 20. And the concentration is 0.2. I'll do the pHs later. Okay, I'll pause it again, set up my next reaction. I got my next reaction set up. I'm reacting HCl with sodium hydroxide. If you remember, I had up here 20 milliliters of 0.2 molar. That will be 4 millimoles. And I add 1 milliliter of sodium hydroxide, and it's 0.1 molar, and so that will be 0.1 millimoles of sodium hydroxide. I do everything in millimoles. 0, 0. So when I'm done, I have 3.9 and 0. And I really don't care about these, but here they are, 0.1 and 0.1. And the concentration of H3O plus will be equal to the concentration of HCl. It's the only thing left in there. The concentration of HCl is going to be equal to 3.9 millimoles divided by the volume total, which over here is 21 milliliters. 21 milliliters. And so that gives me a value, when I plug it in my calculator, of 0.7312 molar. When I put that up there, excuse me, I read the wrong one, 0.1857 molar. 0.1857. Okay? And now I do the same thing for 10. So what I'm going to do down here is set up this reaction and put my numbers in as I go. And so I have HCl plus NaOH yields NaCl plus water, which I really don't care about. And I'm going to have my volume of NaOH here on this side. So the next one I do is 10 milliliters of that. So again, I have 40 milliliter or 4 millimoles. I always start completely back at the beginning. Initial, final, and 10 milliliters of sodium hydroxide will give us 1 millimole. Okay, and when I'm done, I get 3, 0, 1, and 1, so the concentration of HCl will equal the concentration of H3O plus, which is going to be equal to 3 millimoles divided by, what was our total volume? It is 30 milliliters. And I should fill in those total volumes right now. So 3 divided by 30 is 0.1 molar. 0.1 molar. And I always fill these in right away. So this will be 20 and 20 is 40, 50, 59, 60, 61, 65, and 80. Alright, so let's do the next volume. Oops, I didn't mark this volume down. This was V10. Let's do V20. V20, initial, final, 4, 2, 0, 0, 2, 0, 2, 2, concentration of HCl equal concentration of H3O plus. You get tired of writing this, which will equal 2 millimoles over here, right over here, divided by the total volume, which I forgot, so I go up there and look. That's why I write them down. That's 40 milliliters, and so that gives us 0.02 molar. So I write that down up here. Now I want you to go ahead and solve for 50, 59, and 60. Just keep doing them underneath. Volumes of 30, 39, and 40. Just keep doing them underneath. So I'll do volume 30 next. I'm going to pause it and do all those, and you can compare your answers when you're ready. First thing I noticed when I did this was I made a mistake right here. It should have been 0.05 molar, so when I went up I changed that to 0.05 molar. Hope you guys caught that. I don't know if I can slide the screen up. At 30, volume equal to 30, it's 4 and 3, and so I get the concentration of HCl is 1 divided by 50. There's my 0.02 molar. And at 39, it's 4 and 3.9. Different color here. And that gives us 0.1, so it's 0.1 over the total volume, which is 59, which gives us 1.69 times 10 to the minus 3. And then at volume 40, I get my if table. I have 4 and 4, so I don't have any HCl left. I don't have any sodium hydroxide. Guess what? That's a neutral solution. And so in that case, my concentration of H3O plus, I hope you all know this, is 1 times 10 to the minus 7. I'll put that in up here. 1 times 10 to the minus 7th, and the previous one was 1.69 times 10 to the minus 3rd. 1.69 times 10 to the minus 3rd. Okay, a couple more to do. Try that. 41. I'm going to write it out. Okay, I worked out the next 3. Let me put green in here. So here's the volume of 41. Notice at this point I have 4 HCl and 4.1 NaOH, so I have NaOH left over. That's why I drew a line in my chart so I didn't forget. The concentration will be 0.1 millimoles divided by 61 milliliters, which is the concentration of OH, 1.64 times 10 to the minus 3 molar. Same at 45, I end up with 0.5 divided by 65, which gives us 7.69 times 10 to the minus 3 molar. And the final one, at volume of 60 milliliters of sodium hydroxide, I have 4 millimoles of HCl, 6 millimoles of sodium hydroxide, and I end up with 2 millimoles of sodium hydroxide left over, and 80 milliliters, which gives us 0.025 molar. And I filled in my chart up here, and now I can go and calculate pHs with this thing. Well, I got to fill my chart in. Let's see. I have here 1.64 times 10 to the minus 3. 65 is 7.69 times 10 to the minus 3, and 0.025. So when I do my pH calculations, pH is the negative log of H3O plus, so I get a pH of 0.6990, 0.7312, 1.301, 1.699, 2.772, and 7, and 11.215, 11.88, and finally 12.398. Be careful with these. These are the concentrations of OH minus. So when you take the log, you got to subtract or add 14 to the log of those numbers to get the pH. Be careful. This is where people make a mistake. If you find out you got a lower pH than 7, you realize you made that mistake, and just be careful with that. Okay, so I'm going to now make our graph. Okay, at this point, I've drawn the graph here. What you have to be careful of is you need to have this table written down somewhere, where I have volume total, volume of sodium hydroxide versus pH. You're not going to follow this if you don't have it written down, so pause it and figure it out. Okay, so here I go. At a volume of 0, I have about 0.699. You don't have to be real accurate. At 1, it jumps up to 0.7. At 10 milliliters, I am exactly 1, a pH of 1. At 20, I'm 1.3, somewhere in there. At 30, I am 1.69. It's not going up very much. I might be a little bit high here. At 39, it still hasn't gone up. It's about 2.7. And then at 40, you have a pH of 7. That is the shape of the curve. It should look familiar. At 41, it's up here around 11. And 45, it is 11.88. And 60, oops, 11.88. I'm probably a little low maybe. At 60, it's 12.39, something like this. It doesn't matter, and I'm not going to ask you to draw this from scratch. I'll provide you paper. So this is the equivalence point. I always expect you to label it equivalence point. Okay? And this is the titration curve. Notice the shape. You should be very familiar with it. Now, I'm not going to ask you to do all those points. I'm going to ask you to do these 3 points. 0, 1/2 the equivalence point, and out here at 5 after the equivalence point, 45. Now, when you do that, this is what people do. They go like this. That is not it. That is wrong. If you draw that, you flunk. Don't do it. Okay? You got to know the trend line, and you can exaggerate it. You've done this in freshman chemistry. Okay? It goes near vertical at the equivalence point. Always vertical at the equivalence point. Level for strong acid from 0 to 1/2 the equivalence point to out here. Okay? And then vertical in this region. Here, I change my color. Vertical right at the equivalence point, and then it bends back over. Okay? Like this. But that's all you have to do, and I will ask that on the exam. If you have questions, ask.